Hello chemistry students. In this video, you will learn how to name a compound and how to write chemical formula of a compound. Before we start, let's make sure you have your Nomenclature Workshop packet. You can download this packet from Canvas site. The Nomenclature Workshop packet have the nomenclature rules and practice examples. This is from page number 1 to page number 7. There is a reference chart called Nomenclature Reference Chart. This chart will help you during the workshop. And on page number 9, there is a periodic table. You will need to print this whole package from Canvas. Before we start our workshop, I will start labeling few things that we have already learned about elements and the periodic table. The first thing I will make is the stair step to have a clear division between metal and non-metal. This is a very important information, and on the right side of this stair, we have non-metals. And on the left side of this stair, we have all the metals. We also have learned that the metals tend to lose their valence electron and make cation, and non-metals tend to gain electron and make anion. We have learned that metals in group 1A tend to lose their one valence electron and make a positive 1 cation. We will draw a line around the group 1A elements. I will not draw a line around hydrogen because hydrogen is not a metal. So I will only include metals when I'm making this line. So I have all these metals that will make positive 1 cation. Metals in group 2A tend to lose their 2 valence electron and make positive 2 cation. And I will draw a box around these elements as well. Okay. We have learned that elements in group 3A tend to lose their 3 valence electron and make a positive 3 cation. I will put 3 in the parentheses because all the elements in this group don't always follow this rule, but aluminum is the only one that always follow the rule. So what I will do is I will make a box around aluminum. There are 3 other elements in the periodic table that make only one type of cation when they make a compound. These elements are actually the exception from transition elements rule. Most transition elements form variable charges, but zinc always make positive 2 charge. Cadmium always make positive 2 charge, and silver always make positive 1 charge. On the right side of the periodic table, we have non-metals. Non-metals tend to gain electron and make anion to get the noble gas configuration. So non-metals from group 7A tend to gain 1 valence electron and make the charge -1. And I will make a box around the elements that we have in this group that always make -1 ion. I will make it up to iodine because beyond iodine we have radioactive elements and metalloids. Elements in group 6A always gain 2 valence electron to get the noble gas configuration and make a charge -2. So I will make a box around the elements that always follow this rule. When I'm close to the stair, I will not include this Te in it because they don't always follow the same path. They are metalloids. Then from group 5A, we have that they gain 3 electrons to make -3 ion, and these are the elements that always follow this rule. On this slide, you can see that I shaded the elements. I shaded metals with green color. We have group 1A metals with positive 1 charge, group 2A metals with positive 2 charge. Then we have aluminum from group 3A with positive 3 charge, and then zinc and cadmium always makes positive 2, and silver always makes positive 1. Then we have on the right side of the stair, we have non-metals. So I shaded non-metals as yellow so that we can differentiate where we have non-metals and where we have metals. Okay, so now we are ready to learn the first rule. The first thing that we are going to do is to categorize the compound. To categorize, we have to know the type of the elements in the compound. If the elements in a compound are metal and non-metal, then the name of the compound is an ionic compound. And if the compound consists of non-metal and non-metal, or metalloid and non-metal, then the name of the compound is covalent compound. Ionic compounds are divided in type 1 and type 2 ionic compounds. Type 1 ionic compounds are the compounds with metal cation and non-metal anion. Metal cation in these compounds is from S-block metal, and it can be silver, zinc, cadmium, and aluminum. Remember, all these elements are the metals with fixed charge. They always show the charges that we have identified in this table, you can see. Since they always have the same charge, then it doesn't need to be specified in the name. For non-metal anion, we change the ending to IDE. Let's do the example. So a formula that we have is Na2S. So this cation that we have, we will take the name of the anion from the periodic table, and you can find that the name from the periodic table. So it is sodium, and the name for S is it is sulfur, right? So instead of using the whole sulfur, what we will do is we will change this ending with IDE, and it will be sodium sulfide. Okay, now let's do another example. In the next example, our cation is Mg, and the name for Mg is magnesium. So we can write down here magnesium, and then Cl is chlorine. So chlorine, we can write down chlorine, and then we will change this ending with IDE. If you want to know how to change the ending for these anions with IDE, you can always go to the nomenclature reference chart and find what will be the names for these anions from group 5A, 6A, and 7A. Now let's see if we can go to the opposite direction and write the formula from the name. If the name is given, you should be able to write the formula, and this is where it is important to know the charges of the element. You will be using the periodic table to find the charges, and you have to make sure that at the end you have a neutral compound, and this will affect what the subscripts will be. So let's start with the example aluminum oxide. Aluminum, the symbol for aluminum is Al, and the symbol for oxygen is O. The next thing is we have to find their charges from the periodic table. So aluminum, you can see aluminum is +3 always. So we're going to write down +3 for aluminum, and oxygen is -2. Now I have to balance my charges. I need charges that add up to 0 for a neutral compound. How do I work with 3 and 2? to get a neutral or zero charge? Well, they both divide evenly into 6. So if I have 2 aluminum cation and 3 oxygen anion, then the total charge for 2 aluminum cation will be +6, and the total charge for 2 um, and the total charge for 3 oxygen anion will be -6. And if I add all these charges, I will end up to zero or neutral atom. So these numbers that I write in front of these cation and anion, when I write my formula, these numbers are going to be the subscript. Like I have 2 aluminum, so I will write down 2 aluminum like this. This 2 indicates there are 2 aluminum atoms, and there are 3 oxygen, and this will be the formula for aluminum oxide. Let's do it for lithium nitride. So the symbol for lithium is Li, and symbol for nitride is nitrogen. So the symbol for nitrogen is N. The charges I will take from periodic table. Lithium is from group 1A, its charge is +1. Nitrogen is from group 5A, and its charge is -3. So the total charge on nitrogen is -3. What should be the charge? What should be the total charge on lithium to neutralize this -3? It means that I need 3 lithium to have a +3 charge, and then these lithium and nitrogen will give us a neutral lithium nitride. And when I am writing the formula, this number that I write in front of the lithium will be the subscript for the lithium, so it will be Li3N, like this. Next, let's do for barium selenide. So the symbol for barium is Ba, selenide symbol is Se. The charge on the barium is +2 from periodic table. Charge on selenide from periodic table is -2. Here the total charge on selenium or selenide is -2, and total charge on barium is +2. So we don't have to add any numbers. We have the formula BASE. Now let's see what is the shortcut to write these formula. If you notice here, the charge on aluminum has become the subscript of oxygen, and the charge of oxygen have become the subscript of aluminum. So what is happening here is that you can take these charges and cross them down diagonally to get the subscript, and you will be getting rid of this plus and minus sign. So this is your 2, so if you just cross it diagonally and you will bring it here, and you cross this here, and you will end up with the formula. This 3 will be the subscript of oxygen, and 2 will be the subscript of aluminum. Right, and let's see how it goes in the lithium nitride. So the charge on nitrogen is -3. If you cross this down diagonally, this will be the subscript of lithium. That's what you see here. And the charge of the lithium, when you move it down, it will be the subscript of nitrogen, and we don't write 1 if it is just one atom. So the shortcut method is working fine here. But what happened here is when you move the charge of selenium diagonally down, and you are moving the charge of barium down, you will end up the formula Ba2Se2. So now the rule for ionic compound is you will always reduce the subscript to the lowest term. So this, we have 2 and 2, so you can always divide them by 2, and you will end up at BASE. So the shortcut rule is basically cross down charges diagonally to get the subscript. reduce the subscript to the lowest term. Now you can do this practice at your own, and to check your answer, you will be taking the quiz from Canvas. Let's see the rules for type 2 ionic compounds. Type 2 ionic compounds are also consist of metal cation and non-metal anion. There's no change in how we use the non-metal in type 2. It is same as we did in the type 1 ionic compounds. The difference is only in the metal cation. The metals in type 2 ionic compounds are the cations from D, F, and P block. And they are different from type 1 metals is in a way that their charge can vary, and we have to specify their charge with a Roman numeral in a parentheses. So if the charge is +1, we specify the charge like this I, uppercase I in a parentheses, and if the charge is 2, then we do 2 I's, and for positive 3 charge it will be 3I, and for positive 4 charge it is I and a V. That's the Roman numeral for 4. For positive 5 the Roman numeral is just V. For positive 6 the Roman numeral is V and I on the right side. Then for positive 7 we have V and 2 I's on the right side, and then for 8 we have V and 3 I's on the right side. We have not seen charges up to that high number, but these are good to know, the Roman numerals. So all the elements in D block except zinc, cadmium, and silver, they will be the metals with variable charges. Also, all the elements in F block will be the elements with variable charges. So I'm going to shade them so that I know what they are. Also, the elements that we have in the P block under this step stair, these are also the elements that show variable charges. So in this periodic table, I just identified that I have non-metals. All my yellow ones are my non-metals and their charges. Green are the metals with fixed charge, and these pink are the metals with variable charges. Now let's see the example that we have here. So if we are giving name using our type 1 rule, Fe, the name for Fe from periodic table is iron, and for Cl the name is chlorine, and we will change the ending to ide and it will be chloride, right? But this iron is a metal that can be +2 or it can be +3 as well. Now in the next example, we have iron with +3 charge, and if I give name based on our type 1 rule, then it will again be iron chloride, all right? And it will be very confusing if we use this name for both of these compounds. Like for instance, if I say give me a bottle of iron chloride, means I'm not giving a clear instruction if I need a bottle of iron with +2 charge, or if I need a bottle with iron with +3 charge. So we really need to specify their charges in their name. So the way to specify their charge is use a parentheses and specify their charge in this parentheses. So this iron is iron 2 chloride, and this iron is iron 3 chloride. Now, if we are going opposite or backward from name to the formula, so I'm giving name to this iron. So I have iron, and what is the charge on the iron? I know the charge on the iron from this name. So the charge on the iron is Fe +2. Chloride always have -1 charge. I can simply move these charges diagonally like this to get the formula, and the formula will be Fe Cl2. And similarly for this, I have iron plus 3 from here, right? And then I have chloride, and when I move these charges diagonally, I can easily get FeCl3, the formula of the compound. Let's do this example. Sometime to find the charge of the metal with variable charge, we have to do little math. So what we will do is we will start with the known charge on the anion, and we'll figure out what is the charge on the metal cation should be. So anion we have is bromine. Bromine always have -1 charge. We have 2 bromines, so the total charge on the bromine will be if we multiply it by 2. For lead, we don't know what is the charge, and if we don't know, it is unknown. I'll just say that this is my X. When we add all these, they should end up to the 0 for this neutral compound. Now, when we simplify, I have X minus 2 equals 0, and my X is going to be plus 2. You can check your answer because lead is metal, and metals always have positive charge. So this X plus 2 is the charge for lead. So if I'm giving name, it will be lead 2 bromide. Okay. Now let's do for SnO2. Oxygen, charge of oxygen is -2. We have 2 oxygens, so we're going to multiply it by 2. For tin, we don't know, so that is going to be our X. When we add all these, they should end up to 0 for the neutral compound. We have X minus 4 equals 0, and when we solve this, X will equals 2 plus 4. So the name is going to be tin 4 oxide. Now you can do this practice at your own for type 2 ionic compounds, and at the end of the practice you can check your answer from Canvas quiz. Okay, here we have more practice that you can do at your own and check your answers from Canvas quiz. Let's learn rule number 3. This rule involves polyatomic ions in ionic compounds. Poly means many. So group of many atoms with a charge are called polyatomic ions. These polyatomic ions can be cations or anions. You can find their names from the nomenclature reference sheet. First thing that we will do is we will identify our cation and anion. So in this, this NH4 is our cation, and Br is our anion. So for name of the cation, remember that name of the cation is always from the periodic table, or whatever name we have, we don't change. So the name of this cation is ammonium, so we are going to write down ammonium. And then for anion, we are going to change the ending with IDE. So it will be ammonium bromide. Let's do another example. Here we have permanganate ion. Okay, so potassium is our cation and permanganate is our anion. So potassium, we are going to write from the periodic table. And for permanganate, so when a polyatomic ion is involved and it is anion, we are not going to add any IDE, or we are not going to change the ending. We are just going to write down as is. So this will be potassium permanganate. One thing you need to remember when you are writing the subscript of 2 or higher next to a polyatomic ion, you will be using a parenthesis around the polyatomic ion of the formula. So let's do some examples. So magnesium from periodic table, the symbol for magnesium is Mg. Sulfate we will get from here. So sulfate is SO4. Okay, the charge of sulfate is -2. The charge of magnesium is +2. Looks like we need only 1-to-1 ratio if you are moving these diagonally to get the subscript. These 2's will cancel and you will end up with the formula MgSO4. Okay, now for barium hydroxide, barium is from group 2A, so its charge is +2. Hydroxide is a polyatomic ion, okay, and its formula is OH and the charge is -1. When we are moving these numbers diagonally to get the subscripts, for BA it is 1, you don't have to write it, but for OH, if you just write 2 here, it means this 2 is only for hydrogen, but this 2 is actually for both hydroxide. So if it is for both oxygen and hydrogen, you have to make a parenthesis around and around this polyatomic ion, and then there will be 2 outside. Now for iron acetate, so iron is Fe, its charge is +3. Acetate you will get from here, okay, so C2H3O2 and it's -1. When you're moving these charges diagonally, let's see what we are going to do. So when you are moving this 3 here, you really need to make a parenthesis around so that you can separate, you can ensure that this 3 is the charge for all the carbon, hydrogen, and oxygen. We're not going to write 1 because there is no need. Okay, so always remember to use a parenthesis around a polyatomic ion if the subscript is 2 or higher. Now you guys can do this practice at your own. One thing I want to caution you to be careful not mixing up these anion names. Nitrite is nitrogen -3. Nitrite is NO2 -1. Nitrate is NO3 -1. Phosphide is just a phosphorus with -3 charge. Phosphate is PO4 -3 charge. Sulfide is just a sulfur with -2 charge. Sulfide is SO3 -2 and sulfate is SO4 -2. Okay, so you can do this practice at your own and then check your answer on Canvas. Here we have some more practice. Let's learn the rule of binary covalent compounds. So these compounds will be between non-metal or metalloid and non-metal or metalloid. You will be, so the first non-metal or metalloid set that you have, you will be adding a Greek prefix to indicate the number of atom, unless there is only one. And for the second non-metal or metalloid that you have, you will be adding a Greek prefix to indicate the number of atom always, and you will also be adding ending IDE. So the Greek prefixes that we will be using is, you can find them from your nomenclature reference chart. So if you have one atom of that element, we will be using a Greek prefix mono. For 2, it is di. For 3, it is tri. For 4, it's tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So here we have phosphorus. This is the first non-metal. We will use the Greek prefix to indicate the number of atom unless there is only one. So this is only one, so we are not going to use the Greek prefix. We will only say phosphorus. Okay. Now for this chlorine, we will be using ending IDE, so it will be chloride, and we have to indicate the number of atom with the help of the Greek prefix. So for 5 atoms, we will be using penta. Okay, so it will be phosphorus pentachloride. Next example, we have sulfur. So it will be sulfur because it is only one. We are not going to use any Greek prefix for that. Now for oxygen, we will say it is oxide. The Greek prefix for 4 is tetra. So if we write tetra and oxide, okay, when we have two vowels together, we will drop a from the Greek prefix and we will use tetroxide. Okay, so the name will be sulfur tetroxide. Next we have nitrogen, and this nitrogen is 2 atoms of nitrogen, so we will say dinitrogen, and this is 1 oxygen atom, so it will be monoxide. In ionic compounds, we normally reduce the subscripts, but in covalent compound, when you are going from name to the structure, do not reduce the subscripts. So for instance, here you have dinitrogen. So you have nitrogen and it's di, so you're going to write 2 here. Oxygen, there are 4 oxygen tetroxide, so it will be 4, and you are not going to reduce these numbers. You also have to be careful not to mix the covalent compounds with polyatomic ions. So polyatomic ions have charges and covalent compounds are neutral. For example, SO3 is a covalent compound. When you look at the list of the polyatomic ion, you also have SO3. But this SO3 have a -2 charge and it is a polyatomic ion, whereas this SO3 here is a neutral compound. So when you're giving name for this, it will be sulfur trioxide, okay? Versus if you have this a compound between metal and a polyatomic ion, so the name is going to be calcium sulfite. Okay, here you have nitrogen dioxide. Okay, this NO2 looks very similar to the nitrite that we have, NO2 with -1, but this nitrite is a polyatomic ion. So when we are using a polyatomic ion in an ionic compound, it is going to be sodium nitrite. Okay. Now you guys can do this practice at your own, and after that you check your answer from the Canvas quiz. There is more practice for you guys. In this you have all covalent compounds, you have type 1 ionic compound, you have type 2 ionic compound. So make sure that the first thing is you have to decide whether you are going to use a rule for ionic or covalent compound. Same here, you have all mixed up names and you have to give the formulas.